time to shift gears a little bit. Enough on hypothesis testing and model selection. Let's, so where does the doubly non-central F come in? Well, when Akieke was doing all his derivations and stuff, same with Schwartz, the SIC, the AIC, the BIC, in the top line there, big G is the truth. And so we're measuring the information that we get when we compare what we thought to be the truth, which was F, to the truth, which was G. Well, we never know what the truth is, right? That's why we do what we do for a living. We never know what the truth is. We're always trying to figure it out. So it's meaningless to construct an AIC in its own right and say the AIC for this model was 23. That's meaningless. Instead, we're comparing the AIC for one model with a different one. And so the term that involves the truth, the big G, gets canceled, which is an admission that neither of the two models under consideration are correct. They're both false. But I just was asserting to you that we can, when we're comparing the two AIC, there's an implied F statistic there. Well, because both models are wrong, the implied F statistic must be doubly non-central F, because they're both wrong. Remember, a central F is predicated on the null hypothesis being true. Well, now we're just trying to distinguish between two models, both of which are wrong. And we admit they're wrong. But we're trying to decide which one is the least wrong by comparing their AICs. And because they're both wrong, the garden variety F statistic implied by the AIC is doubly non-central F. And so we would be reading the critical values much bigger than the way that people just pursuing F-tests blindly would be reading them. People who are blindly applying F-tests are always reading out of a set of central F tables. Now we know there are a bunch of circumstances under which we want to use different tables.
Is that the special case when the denominator is not non-central? We talked earlier.
No, it's the numerator. Earlier, the numerator was non-central. The denominator under the mean square error and risk test and the garden variety F test, it's always the numerator that's non-central chi-square, and the denominator is always central chi-square. Because remember, in the denominator of the garden variety F test, we are computing the residual sum of squares from the unrestricted model. The unrestricted model means we've dumped all the variables into it. We haven't constrained any of them. So if we're not constraining any of them, it can't be wrong by definition. Okay, but if the null hypothesis is wrong, then the chi-square in the numerator must be non-central. You seem to be having trouble with this, yeah? A little bit.
Okay, let's stop it.
We talked about power earlier in this, the power of a test earlier in the semester, right? And the simple example that I had in the lecture notes was Vitasynthetics, I think. And this new drug that reduces blood pressure or cholesterol or something. Anyway, there's an example in the lecture notes somewhere about the power of a test and this new drug that's invented called Vitasynthetics. And under the null hypothesis, the proportion of users of the new drug who are helped by it is 10%, and under the alternate, the true proportion of people helped by the drug is 20%. So under the null hypothesis, the test statistic had a normal distribution centered at 0.1. And under the alternate hypothesis, the test statistic had a normal distribution centered at 0.2, right? Remember that example in that discussion? And so we could figure out, so the picture of what we were doing, so there's the null and the alternate hypothesis, and our null hypothesis was that the mean was 0.1, the alternate was that the mean was 0.2. So that we had a very specific alternate hypothesis, and we picked out, we said we want to reject a true null only 5% of the time. And so the area in the tails was 2.5%. Under the alternate, what's the probability of rejecting the null? When the alternate is the one that's correct, the probability of rejecting the null was all that area. So when we're deciding whether or not to reject the null, under the null hypothesis, the normal random variable is centered, notice the choice of words, is centered on 0.1. When the alternate is what's true, our normal random variable is no longer centered on 0.1, it's centered on 0.2. Now flash forward to our discussion about an F-test. Under the null hypothesis, and we construct our F for this test is the restricted sum of squares under the constrained model, when we impose that restriction, minus the residual sum of squares under the unconstrained model, where we don't impose that over some number of restrictions, over RSS big omega divided by n minus k. Well, under the null hypothesis, there is no difference between those two numbers under the null hypothesis. And so the chi-square is constructed out of a random variable that's centered, a normal random variable that's centered at 0. This residual sum of squares in the denominator, if the null hypothesis is true, there's no harm and no foul in including the price of meat, bread, and family size in the model, because statistically those coefficients will turn out to be 0. So the denominator is constructed out of random variables, normal random variables, centered on 0, regardless of whether or not the null hypothesis is true. When the null hypothesis is false, these two are going to be quite different. They'll be much different numbers. The chi-squares in here are not going to be centered on the origin. Did that clear things up at all? So when we were doing a simple test of hypothesis, we said under the null hypothesis, the mean was centered at point 1. And we asked, where is the random variable centered when the null hypothesis is not true? And the fact that we can reject the null hypothesis with such high frequency is because it's no longer centered back here, it's centered up here. Well, the same thing is going on here. The fact that we reject as the null hypothesis becomes false, the fact that we reject it with such high frequency is because the random variable is no longer centered at the origin. It's centered somewhere else because the alternate is